Good morning. Today we will study the concept of change of variables from Cartesian to polar coordinates. Question arises, why do we need to change the coordinates, say from Cartesian to polar coordinates or from polar to Cartesian coordinates? It all depends on the problem under study. For example, if we are considering or if we are studying the problem of heat transfer through a certain cylindrical disk from one place to the other place, if we try to study this heat transfer through that cylindrical slab or cylindrical disk by considering or by using the Cartesian coordinates, it becomes difficult for us to describe the situation. However, if we use the polar coordinates, the system can be analyzed very easily. On the other hand, if we are studying the propagation of sound waves through a certain medium, the Cartesian coordinates are more helpful or more easier than the polar coordinates. So depending on what problem we are studying, we have to decide which system of coordinates is to be adopted. If it is so, then on many a number of occasions, the situation arises where we need to make the change of the coordinates, say either from Cartesian to polar or from polar to Cartesian. So how to do this? So let us study here. For example, if we have a certain function f, which is the function of say two independent variables, say x and y, where x and y are the Cartesian coordinates, and these variables x and y are further the functions of two another variables, say r and theta, where r and theta are the polar coordinates, and these Cartesian coordinates or rectangle coordinates and the polar coordinates are related to each other by the relations x is equal to r cos theta and y is equal to r sin theta. So here we are given the function f, which is the function of the two independent variables x and y. X and y are the rectangular coordinates or Cartesian coordinates, and these Cartesian coordinates are related to the polar coordinates r and theta by these relations. Now, as we know that if there occurs certain change in the value of r, both the values of x and y changes. If the values of x and y changes, there occurs certain change in the value of the function f. Or else, if there occurs certain change in the value of the variable theta, again there occurs certain change in the values of x and y, so that the value of the function f once again changes. So we can directly study the variation of f either with respect to r or with respect to theta. So the variation of f with respect to r is given by the expression, say dou f by dou r is equal to dou f by dou x into dou x by dou r plus dou f by dou y into dou y by dou r. This is the expression for dou f by dou r. Similarly, we can study the variation in f with respect to theta also, and we get the expression for dou f by dou theta as do f by do x into do x by do theta plus do f by do y into do y by do theta. So here, since x and y are the functions of r and theta, we can obtain the expressions for do f by do r, do y by do r, do x by do r, do y by do r, do x by do theta, and do y by do theta. So differentiating x partially with respect to r, we get do x by do r to be equal to cos theta, and do y by do r is equal to sin theta. Do x by do r is equal to cos theta, and do y by do r is equal to sin theta. Similarly, we get the expression for do x by do theta to be equal to minus r sin theta, and do y by do theta is equal to r cos theta. So using these expressions for do x by do r, do y by do r, do x by do theta, and do y by do theta in the expressions for do f by do r and do y by do theta, we get do f by do r is equal to do f by do x as it is into do x by do r. Do x by do r is cos theta plus do f by do y as it is into do y by do r is sin theta. Or this expression can be expressed as do f by do r is equal to cos theta do f by do x plus sin theta do f by do y. So this is the expression for do f by do r. Similarly, we can obtain the expression for do f by do theta. We get do f by do theta to be equal to do f by do x as it is into do x by do theta is minus r sin theta plus do f by do y into do y by do theta is r cos theta. Or this expression can as well be expressed as do f by do theta is equal to minus r sin theta do f by do x plus r cos theta do f by do y. So we have the expressions for do f by do r and do f by do theta. Now we want to obtain the expressions for do f by do x and do f by do y. Say, we'll rewrite these expressions here. Do f by do r is equal to cos theta do f by do x plus sin theta do f by do y, and do f by do theta is equal to minus r sin theta do f by do x plus r cos theta dou f by dou y. So we have these two expressions for dou f by dou r and dou f by dou theta. Now from these expressions we want to obtain the expressions for dou f by dou x and dou f by dou y. Say the expression for dou f by dou r is equation 1 and expression for dou f by dou theta is equation 2. Now from these two expressions, by solving these two equations simultaneously, we can obtain the expressions for dou f by dou x and dou f by dou y. So when we want to obtain the expression for dou f by dou x, we have to eliminate dou f by dou y, and when we want to obtain the expressions for dou f by dou y, we have to eliminate dou f by dou x. So in order to obtain the expressions for dou f by dou x first, we have to eliminate the term containing dou f by dou y from equation 1 and 2. So in order to eliminate the term of dou f by dou y from equations 1 and 2, what we need to do is we have to multiply equation 1 by r cos theta minus equation 2 multiplied by sin theta. So multiplying equation 1 by r cos theta and equation 2 by sin theta and taking the subtraction of the two expressions, we can eliminate the terms containing dou f by dou y so that we can obtain the expression for dou f by dou x. So equation 1 multiplied by r cos theta will give us r cos theta dou f by dou r is equal to r cos square theta. Cos theta into r cos theta is r cos square theta dou f by dou x plus sin theta into r cos theta is r sin theta cos theta dou f by dou y. So by multiplying equation 1 by r cos theta, we get this expression, and multiplying equation 2 by sin theta, we get sin theta into dou f by dou theta is equal to minus r sin square theta into dou f by dou x plus r cos theta into sin theta is r sin theta cos theta dou f by dou y, and subtracting equation this 2 by from equation 1 by multiplying by r cos theta and sin theta, the signs of the terms in the second expression will get reversed. So this term will become minus, this term will become plus, and this term will become minus. So this term r sin theta cos theta dou f by dou y and minus r sin theta cos theta dou f by dou y will get cancelled, so that we get the expression as r cos theta dou f by dou r minus sin theta dou f by dou theta is equal to r cos square theta dou f by dou x plus r sin square theta dou f by dou x. So we can take r and dou f by dou x common, and into bracket we can write as cos square theta plus sin square theta into dou f by dou x. So the value of this bracket is 1, as you know well, so that we get the expression for r dou f by dou x is equal to इक्वेशन पाहायचे होते मला. बरं, ठीक आहे, बंद करतो. So after subtracting the two expressions, we get this expression, and from this expression we can obtain the expression for dou f by dou x like this. So the value of this bracket is 1. So this is r dou f by dou x is equal to r cos theta into dou f by dou r minus sin theta into dou f by dou theta. And from this, dividing both sides of this expression by r, we get the expression for dou f by dou x to be equal to cos theta dou f by dou r minus sin theta upon r into dou f by dou theta. So this is the expression for dou f by dou x. Similarly, we can obtain the expression for dou f by dou y from equations 1 and 2. So this expression for dou f by dou x, we require it. So we'll write it here. Dou f by dou x is equal to cos theta dou f by dou r minus sin theta upon r into dou f by dou theta. So this is the expression for dou f by dou x. So now we'll obtain the expression for dou f by dou y. So to obtain the expression for dou f by dou y, we have to eliminate the term of dou f by dou x from these two expressions. In order to eliminate the term of dou f by dou x from equation 1 and 2, what we need to do is we have to multiply equation 1 by r sin theta and equation 2 by cos theta, equation 2 multiplied by cos theta, and take the addition of these two expressions. So multiplying equation 1 by r sin theta and equation 2 by cos theta and taking the addition of these two expressions, we'll get the expression for dou f by dou y. So equation 1 multiplied by r sin theta will give us r sin theta dou f by dou r is equal to r sin theta cos theta into dou f by dou x plus r sin square theta dou f by dou y, and multiplying equation 2 by cos theta, we get cos theta dou f by dou theta is equal to minus r sin theta cos theta dou f by dou x plus r cos theta into cos theta is r cos square theta dou f by dou y. So taking the addition of these two expressions, this term will get cancelled. So we have r sin theta dou f by dou r plus cos theta dou f by dou theta is equal to r sin square theta dou by dou y plus r cos square theta dou by dou y. R and dou by dou y can be taken common, and we can write this as r into bracket sin square theta plus cos square theta into dou f by dou y. And the value of this bracket is 1, as you know. So we get the expression for r dou f by dou y, or dou f by dou y is equal to r dou f by dou y is equal to r sin theta dou f by dou r plus cos theta into dou f by dou theta. And dividing both sides of this expression by r, we can write the expression for dou f by dou y. Therefore, dou f by dou y will be equal to sin theta dou f by dou r plus cos theta upon r into dou f by dou theta. So this is the expression for dou f by dou y. So here we have the expressions for dou f by dou r and dou f by dou theta, and from the expressions for dou f by dou r and dou f by dou theta, we have obtained the expressions for dou f by dou x and dou f by dou y. So we have changed the coordinates from Cartesian to polar, or we can change from polar to Cartesian. So if we are given the system in Cartesian coordinates, we can change to polar form, or else if we are given the system, describe the system in polar form, polar coordinates, we can change them to the Cartesian coordinates. So for that purpose, we have these expressions for dou f by dou r, dou f by dou theta, dou f by dou x, and dou f by dou y. So that is about this change of variables from Cartesian to polar coordinates. Let us see one example of how to change the variables from Cartesian to polar form, and whether once if we change these coordinates from one form to the other, whether the result we get remains same or does it change. Let us see with the help of one problem. So let us consider we are given a function f. Say f is the function of x and y expressed in the form x square plus y square bracket raised to half into y upon x. This is the function f, which is the function of the rectangular coordinates or Cartesian coordinates x and y. And you are asked to obtain the expression for dou f by dou x directly and by changing the variables. X, y to r and theta. So you are asked to obtain the expression for dou f by dou x once by directly. Since f is given to be the function of x and y, directly we can differentiate f partially with respect to x. We will get the expression for dou f by dou x. This is by one method. And secondly, you are asked to change these rectangular coordinates or Cartesian coordinates to the polar form or in terms of r and theta, and then you are asked to obtain the expression for dou f by dou x. So let us first obtain dou f by dou x directly. So if f is equal to x square plus y square raised to half into y by x, what will be dou f by dou x? Dou f by dou x will be given by direct method. By direct method, dou f by dou x will be given by Kyle dou by dou x. Dou by dou x will be equal to 1/2. We have to use the product rule here for differentiation. 1/2 x square plus y square raised to minus half into 2x into y by x as it is, plus first term as it is, x square plus y square raised to half into differentiation of y by x partially with respect to x will be minus y upon x square, or this can be rewritten. So this two will cancel, this x will cancel, and we can rewrite this expression as dou f by dou x is equal to y upon x square plus y square raised to half. This minus sign will appear here, minus x square plus y square raised to half into y upon x square. So this is the expression for dou f by dou x by directly differentiating it partially with respect to x. Similarly, now we can obtain the expression for dou f by dou x by changing the variables from x, y to r and theta. So by changing the variables means how to do it. Let us see. If we have this right angle triangle, so this is x, this is y, and this is theta. We have this right angle triangle. So in this right triangle, we have this side x, this side y, and this is the angle theta. So by using Pythagoras theorem, what will be the hypotenuse of this right angle triangle? The hypotenuse, say r will be equal to under root x square plus y square. Under root x square plus y square is nothing but r. And theta, tan theta will be expressed as, tan theta will be equal to opposite side upon adjacent side, y upon x. This is the expression for r and tan theta. So again we can write the expression for sin theta and cos theta. Sin theta will be equal to y upon r, and r is nothing but under root x square plus y square, and cos theta is expressed as x upon under root x square plus y square. So we are given the function f in the form x square plus y square raised to half into y upon x. So what does this first term represent? This first term, x square plus y square raised to half, is nothing but r. So this is r into y by x is nothing but tan theta. So f is expressed in the polar form, or in terms of polar coordinates, as f is equal to r tan theta. And once now we know the function f in terms of the polar coordinates r and theta, now we want to obtain the expression for dou f by dou x. This now we have seen the expression for dou f by dou x given as we have the expression for dou f by dou x to be equal to cos theta dou f by dou r minus sin theta upon r into dou f by dou theta. Dou f by dou x is expressed as cos theta dou f by dou r minus sin theta upon r dou f by dou theta. So let us obtain the expression for dou f by dou r and dou f by dou theta. If f is equal to r tan theta, what will be dou f by dou r? Dou f by dou r will be simply equal to tan theta. So this is cos theta into tan theta minus sin theta upon r as it is into dou f by dou theta is r into differentiation of tan theta is sec square theta. Sec square theta. So this r gets cancelled. So we have dou f by dou x is equal to cos theta into tan theta. Cos theta चा एक्सप्रेशन काय आहे तो आपण आता cos theta is nothing but x upon x square plus y square raised to half into dou f by dou r is tan theta. Tan theta चा expression, tan theta is y upon x minus sin theta is y upon x square plus y square raised to half into sec square theta is x square plus y square upon x square. This is the expression for sec square theta. So here this x will cancel. So what we'll get is dou f by dou x. Dou f by dou x is equal to y upon under root x square plus y square, or x square plus y square is to 1/2. It is one and the same thing. Minus, this is in the numerator x square plus y square, and in the denominator it is x square plus y square is to half. So this will give us x square plus y square raised to half into y upon x square. So this is the expression for dou f by dou x by changing the variables from Cartesian form to the polar form. So even if we change the variables from Cartesian to polar form and obtain the expression for dou f by dou x, this expression for dou f by dou x by changing the variables is found to be same as the expression for dou f by dou x obtained directly by differentiating the given function f of x and y. So that is about the change of variables from Cartesian to polar coordinates. Okay, thank you. The next part we discuss in the next video.